Alright, in this video we're going to look at equations where the variable that you're trying to solve for may occur on the left and the right side of that equal sign. Now, the word identity comes from or is used whenever you have an equation that has infinitely many solutions. So like you might be thinking that an equation can only have one solution, it's equal to 1, 4, negative 3. But there are situations where you will solve and you'll be working it through an equation where it can actually, you can use any number to make that equation work out. So for example, if you have 2x plus 10 and that's equal to 2 times the quantity x plus 5, well, if we're solving for the value of x, we know that we have to simplify either side of the equal sign first. So the 2x plus 10 is fine. On the other side of the equal sign, we have 2 times the quantity x plus 5. So let's use the distributive property here. Distribute that 2 to the x and to the 5. So 2 times the x, we're left with 2x. And then we also have to distribute the 2 to the positive 5, like so. And then we're left with a plus 10. So then rewriting the rest of the equation, 2x plus 10. Well, if you notice, both expressions on either side of the equal sign is exactly the same. That means that any number that you substitute in for the x would work. We call this an identity. So just keeping that word identity in mind, let's look at example number 1. So we have to solve for the variable, or solve for an equation with variables on both sides. So we're looking at 15 plus 4a equals 9a minus 5. So we have the 4a on the left side of the equation and we have the 9a on the right side of the equation. So before we never did this, but because we have variables on both sides, I want to create a divider. And again, that equal sign is our divider for the left side and the right side. So when solving an equation where variables occur on both sides, you have to make a choice. You have to make sure that whatever side you choose, you have the variable terms on one side of the equal sign, not necessarily the left, and the other terms, or the constants, on the opposite side. So that's the goal. So what I'm going to do is we need to make sure that we have a 0, so like when we cancel it out, I'm going to move the variables to the right side. So I need to make sure that this 4a becomes a 0 on this side. And in order to do so, I'm going to subtract 4a from both sides because that's the inverse operation of positive 4 or adding 4a. So if I subtract the 4a from this side of the equation, I must do that to the other side. And I'm going to line it up with the like term, the term with the a in it as well. So I'm going to simplify. I have 15 plus 0 equals, and then 9a minus 4a gives us 5a, and then write down minus 5a. So if you look at the right side is the only side of the equation with the a now. It's not occurring on both sides, and that's key. Do we always have to move it to the right? Or I'm sorry, do we always have to put the variables on the right side? Absolutely not. I did so because I knew that the inverse operation of addition was subtraction, and if I just took 9 minus 4, that would give me a 5a. I'm not having to deal with negative numbers. So once you've decided that the a is on the right side, I'm going to move the constant terms, the other terms, on the other side. Okay, so then the 5a, we're subtracting a 5 from it, so then we still got to make that 0. And so the inverse operation of a minus 5 would be to add 5 to both sides. And I'm going to line up the 5 with the 15. Again, we don't need that 0 here, but just to make a point that 4a minus 4a is 0. So we're going to simplify that equation. We get 20 equals 5a. So knowing that we have 5a equals 20, we're multiplying the a by 5. Now we got to make this 1. So we got to keep the a here, so we got to make sure that that 5 turns into a 1. In order to do so, we use the inverse operation of multiplication. So we're going to divide both sides by 5. We're left with a 1a equals 4. And again, we don't write down the 1 anymore. We don't have to. A is equal to 4. Alright, example 2, we have 4t minus 12 equals 6 times the quantity t plus 3. So when we're solving our equation, again, we simplify both sides of the equal sign regardless of what's happening. So we have a 4t minus 12, can't do anything there, but we have a 6 times the quantity t plus 3. So I'm going to divide both sides, or not divide, but separate the two sides from the equal sign left and right. And then I'm going to distribute the 6 to the t to get 6t plus, oh, I'm sorry, we're going to 6t times a positive 3 now. So that'll give me a plus 18. Now the right side's simplified. We can't really combine 16 and 18. They're not like terms. So we're going to write down the rest of the equation. 4t minus 12 equals 6t plus 18. Okay, so like in the previous example, we have to choose where we want our variables to go. The variable terms need to be on the one side, and then once you decide to put the variable term on that specific side, everything else has to go on the opposite side. So on one side, I'm going to move the 4t by using the inverse operation of a positive 4t. So a lot of us might be thinking, well, we have a minus sign, so we're subtracting, so we got to add. But how are we going to make this 4t 0? Well, in order for us to do that, we have to subtract 4t from both sides. That's why we always say we have to make that 0. So 4t minus 4t will give us 0, so we have to do that to one side and the other. And I'm going to line it up with the 6t, its like term. And then we simplify. So we're left with a 4t minus 4t, which is 0, minus 12 equals 2t plus 18. Now that we've moved the variable terms on one side of the equal sign, everything else on the right side of the equal sign has to go on the opposite side. So right now we're adding a 18 to the positive 2t. So we're going to move the positive 18 and make that 0 so that we are just moving all the constants to the opposite side of where we put the variable term. So to make that 0, the inverse operation of adding 18 would be to subtract that 18. So I do that to both sides, so negative 12 minus 18 gives us negative 30. So negative 30 equals 2t plus 0. We don't need that 0 anymore. And finally, we are left with a 2t equals negative 30. And to make this 1, because we want to keep that t to represent the variable that we have to solve for, we're going to divide both sides by 2. So we're left with 1t equals negative 15. And we can rewrite it as negative 15 equals positive t. Alright, so example 3, the directions are a little bit different. It says identify the number of solutions of an equation. In all the problems that you'll get, it won't say identify the number of solutions. It'll say solve. So this example is just specific to us so that we can get or become aware of, well, do we actually have a solution or do we have an identity? Where identity is where you have multiple or infinitely many solutions. So looking at A, we have 4x plus 5 equals 4 times the quantity x plus 5. So we know that if we solve our equation, we first have to simplify the left or the right side of the equal sign. So I'm going to distribute the 4 to the x by multiplying, so 4 times x, plus distribute the 4 to the positive 5. And 4 times positive 5 gives us 20 equals 4x plus 5. So now we have the variable on both sides of the equal sign. Like before, we have to choose where we want to put it. So on one side of the equal sign, I'm going to move the 4x to the left-hand side this time. So we got to make sure that becomes a 0. So we're going to subtract 4x from both sides. And a lot of people just stop here and get confused. Mathematically and algebraically, just work it out. Let's see what happens. So we know that 4x minus 4x gives us 0x here. And we're left with plus 5 equals 4 minus 4x gives us 0x plus 20. And you're thinking, well, what is happening here? You have 0x here and a 0x on the other side. Well, again, 0 times x or 0 times anything will give us 0, so we'll keep simplifying further. And we're left with 5 equals 20. Now, if you solve an equation and you have a situation where a number equals a different number, does 5 ever equal 20? Absolutely not. 5 is not 20. So when you have the situation, there aren't any solutions. So this is considered no solution. it's very important that you do work it all the way through and don't get caught at this step and say, well, what's happening here? Keep working it out, and then you'll see, wow, 5 does not equal 20, or whatever number or whatever situation you have. It'll give you no solution if this is the case. Now looking at B, same situation, not where we have no solution, but when you have an equation where variables occur on both sides of the equal sign, first simplify either side. So we have to simplify the right side first, so we're going to distribute the 3 to the 2x, so we get 6x, and also distribute the 3 to the negative 1, we get a minus 3. So that's equal to 6x minus 3. So 6x minus 3, if we keep going, well, right away we have two expressions that are exactly the same. When you have two expressions equal to each other that are exactly the same, that is considered an identity. We have infinitely many solutions for this equation. So thank you very much for watching. Again, write down any questions you have on the right side and I'll address them tomorrow. Good job, and make sure that you guys continue to watch the videos and focus on just the video and listening to it versus watching a movie and watching the video. So keep your focus, keep going, guys. You guys are doing great.